guys, let's get one more video on arc length. We need to calculate the arc length of the curve x equal to the square root of 4 minus y squared between y equal to negative root 3 to y equal to positive root 3. So, looking at the limit, they tell us how our formula should look like. So our formula must end with dy. So as an N6 student, you go to page 7 of your formula sheet, you look for the formula s equal to the integral from c to d, the square root of 1 plus dx over dy, all that square dy. So that's our formula. Then the formula should take us through the whole process. So there we've got our problem as x equal to the square root of, which you can capture it as 4 minus y squared, all this to the power 1 over 2. So that's the same thing as the square root of. So the fact that x has been made the subject, you can look for your dy dx straight away by taking the chain. So we'll get dx over dy being equal to, when you differentiate the outside, you'll get 1 over 2 into 4 minus y squared. You subtract 1 from there, you get negative 1 over 2. Then now you step inside and differentiate the core function. That will give us the derivative of 4 minus y squared to be minus 2y. So that is what we get. And once you are done with your derivative, make sure you try to simplify it and get a positive exponent. So this negative 2 will take care of that 2. So you will be left with negative y at the exponent divided by the square root of 4 minus y squared, because that negative will drop to the denominator as a positive and becomes the square root. Then we can do our squaring. So if we go to dx over dy, all that square, if you square the negative, it becomes a positive. Then you square the square root goes away, you are left with 4 minus y squared. So that is how you get your dx over dy, all that square. So that is one option. Another option that candidate can also use is the option of implicit differentiation. So since we've been given x equal to the square root of 4 minus y squared, the candidate who is not comfortable playing around these halves, these fractions, can start by squaring both sides to get x squared is equal to 4 minus y squared, because if you square the left side, it just takes out the square root. Then now you differentiate implicitly, so you get the derivative of x squared giving us 2x dx over dy. Each time you differentiate x, it will create dx over dy is equal to, you differentiate here, you get negative 2y. Then you make dx the subject, dx over dy the subject. It will give you negative 2y over 2x, which is negative y over x. Then you square both sides, you get dx over dy. All this square being the square of this. If you square negative y, you get y squared. You square x, it gives you x squared. But knowing that in your formula we are only interested in x, in y, sorry. You see the formula says so. It means we must look for the meaning of x squared. And you see the meaning of x squared from where you started squaring. So x squared is giving us 4 minus y squared. So you see, we arrive at the same place. So you can choose to first square both sides first, use implicit, or use the chain. So we are done with dx dy, all that square. We need to add 1 to it. So if we go to 1 plus dx over dy, all that square, that means we are taking 1 plus y squared and 4 minus y squared. So if you simplify that, your LCD, because 1 is like 1 over 1, which you say your LCD is 4 minus y squared. If you use the LCD divider and multiply there, you get 4 minus y squared, then followed by that positive sign. With the LCD divide itself, it's 1 times y squared, it's y squared. You see that you have negative y squared plus y squared, which gives us 4 on 4 minus y squared. So that is what we have as the item that will go under the square root in our formula. So it's time now to start integration. So we're integrating from negative root 3 to 3. So you get negative root 3 to 3, the square root of 4 on 4 minus y squared dy. So with that, the square root is flexible when it comes to division. So this becomes the integral of the square root of 4 divided by the square root of 4 minus y squared dy from negative 3 to 3. The square root of 4 is a 2, so we get 2 it being a constant from negative 3 to 3. So we are now having only dy up there on the square root of 4 minus y squared. So up to where we are, if you look at what we have, you see that each time you are doing integration as a mathematics student, and it reduces to 2 terms which are in the form of a quadratic, then it's already telling you that you should have a look at your formula sheet. So on page 4 of our formula sheet, we will try to search for that formula that resembles the what we've written there. So I'll go to my N6 formula sheet. Such formulas are usually on page number 4. I search for a formula that resembles that. So going through my formula sheet, I've seen a formula that looks like this: the integral of dx on the square root of a squared minus b squared x squared being equal to 1 over b, the arc sine of bx over a plus c. So that's what I've seen on my N6 formula sheet, which is something that has a close resemblance to my problem. So I will then copy my problem next to it and do the matching. So my problem is in terms of y, dy on the square root of 4 minus y squared from negative root 3 to root 3. So if I'm matching, you see that everywhere there is dx in that formula, I'm putting dy. That means everywhere there is x, I'll put y. Then 4 will be replacing a, y will be replacing x. Then obviously b is a 1 since there is nothing there. So with that matching, we have it 1 over 1 because b is a 1. Then the arc sine of in here, I'll be having b is a 1, my y is my x. So I get that. Then my a is a squared is a 4, that means a is a 2. So that's all I have from negative root 3 to positive root 3. So I now substitute my limit, so I'll just be having the arc sine of root 3 over 2. If I put root 3 in the place of y, that's my upper limit, then my lower limit will be the arc sine of negative root 3 over 2. So all I need now is, oh, I'm forgetting that there was a 2 outside as a constant. So yeah, I must get the 2 there as a constant, the same thing there. So all I need now is my calculator to do the rest for me. And you remember with trigonometry, we must make sure our calculator is in radians. So I'm going to do my calculator. I need the arc sine of the square root of 3 on 2. My calculator is already in radians. Then I will minus the arc sine of, I will have negative root 3 on 2. So that's what I get. So I've taken this arc sine of root 3 over 2 minus the arc sine of negative root 3 over 2. I'm just confirming that is what I've done. Yeah, it gives me 2 third pi, then I'll multiply by 2 because I didn't use the 2, that is a common factor. So I multiply my answer by 2. So my answer is giving me 4/3 pound. So that is what I see as my answer. So that is it, guys. Thank you very much.